In this video, we are going to calculate escape velocity, the velocity required for an object to move it from the Earth's surface to the out of the gravitational field. It's called escape velocity. First of all, we know that as the object of mass m at the surface of Earth, if we throw an object up in upward direction, it will attain the certain height, say h height, and then it will their velocity will become zero and its direction of velocity will be reversed and it will strike to the ground with the same velocity. And if we move the object, throw the object with a greater velocity, then it will attain the height which is required to an object to go out of the gravitational field, and where the gravitational force is equal to zero, then this object will not come back to the earth, and here its velocity is zero and their velocity at infinity is zero, where the gravitational force is zero, then it will not come back to the ground. This velocity, the minimum velocity which is required for an object to move it from the earth's gravitational field to infinity, is called escape velocity. This escape velocity we are going to calculate. First of all, we know that the work energy principle, which tells us that the loss in kinetic energy is equal to gain in potential energy. As we throw the object in upward direction, its kinetic energy will decrease, and this object is going in upward direction, its kinetic energy will decrease, but its potential energy will increase. As the potential energy at infinity is equal to zero because there is no longer in attraction with the gravitational field, and the potential energy at the surface of Earth at this point, the potential energy is equal to minus capital G small m capital M divided by capital R, the radius of Earth. This potential energy is in negative, and this potential energy is zero, which is greater than the negative potential energy. Hence, we are saying that the potential energy increases as we go in upward direction. In upward direction, the kinetic energy decreases and the potential energy increases. Hence, the loss in kinetic energy is equal to the gain in potential energy. The loss in kinetic energy will be written as the kinetic energy initial minus kinetic energy final. Because this is loss, we will write the initial before and then final, and the gain in kinetic energy will be equal to the potential energy final minus potential energy initial. Initial kinetic energy is half mv square. The final kinetic energy is zero because here at infinity infinity the velocity becomes zero. The final potential energy is zero, and the minus initial potential energy minus capital G small m capital M divided by capital R, and half mv square is equal to this minus and minus become positive, and G M capital M divided by capital R. This small m and this small m will be cancelled out. Then we will get to the left side v square is equal to 2 capital G capital M divided by capital R. And if we take the square root on both sides, then our velocity, the escape velocity, will become the square root of 2 capital G capital M divided by capital R. As we know that the gravitational force by the Newton's gravitational law, F is equal to capital G small m capital M divided by the capital R square at the surface of Earth, and this gravitational force is also equal to the weight of the object mg capital G small m capital M divided by R square, and the mass from the both sides mass of the object is cancelled out. Then the small g multiplied by the capital R will become capital G, capital M divided by capital R. The R square, because there is R square and then one R is multiplied to the left side, we will get the GR is equal to capital G, capital M divided by capital R. Uh, if we plug these values in equation 1, our V square will become the square root of 2G and R. If we plug all the values of small g, which is gravitational acceleration, and capital R, which is the radius of Earth, V square will become 2 multiplied by 9.8 and multiply the radius of Earth, which is 6.4 into 10 raised to power 6, and square root. Then the V square will become 11.2 kilometer per second. If we want to throw an object out of the gravitational field, then we have to throw it with a velocity of 11 kilometer per second, neglecting the air friction. Thank you for watching.